Hi everyone, welcome back to another episode of our CCIR Spotlight interviews. Today I'm here with Neer, who's been looking at maths and physics, and specifically looking at the astrophysics of high-density objects and how we can apply Einstein's theory to that. So I'm going to start by letting him introduce himself and the title of his project and telling us a little bit more about what he's been working on.
Yeah. Hi, my name is Neer, and I'm currently a 12th grader studying in the International School Bangalore in India. And I've been interested in physics and math from the very beginning, and patterns are something that fascinated me. So I've been interested in applying math in physics, especially in understanding the workings of the universe. And this was something I also found interesting due to my love for sci-fi movies such as Star Wars or Interstellar. And I always wondered, is what they depict in those movies actually possible, or is it just theoretical? And it was just another one of the reasons why I opted for this course. So, like you said, the title of my course was The Astrophysics of High Density Objects. And we covered quantum electrodynamics, the theory of relativity. And as a final project, I have focused on using ray tracing methods to visualize black holes and wormholes in deep space. So just a small overview on my project. I felt like the theory of relativity was not actually a theory. I felt it's something that has to exist for the universe to work the way it is. And without losing the essence of the theory, I felt Einstein suggests that objects with a mass distort space-time. And we don't really live in a 3D world. We live in 4 dimensions. And the 4th dimension is considered space-time because he believes that time is relative and not absolute. So I started off my project by modeling particles such as electrons or protons, particles with a charge on flat space-time. And I modeled how they move in the presence of a magnetic or electric field. And I think this was just the introduction to what the course was actually about. So all of this code was something that my mentor, Dr. Bart, and my teaching assistant, Seppa, really helped me in to develop the code. And from here, I think we took it further and we implemented the theory of general relativity, which involves massive objects. And if you think of space-time as a fabric, massive objects warp the space-time, which means that light does not travel in a straight line anymore. It gets bent. And this bending of light is something that we can use to visualize objects in deep space, because black holes are black and they sort of suck in all light that gets too close. So we can't actually take a photo of the black hole, but we can take a photo of the gravitational lensing that occurs around the black hole. So my project focuses on modeling multiple light rays to sort of get an idea of what a black hole would look like in deep space. And I'm currently working on implementing that for a wormhole.
Which sounds both incredible and, a very high level project here as part of the Future Scholar program, but then also a very interesting area of research for you to do. I mean, when you began the project, how much astrophysics had you already started? Was this, an area obviously you said you were very interested in, but how much had you done? Because I know you said you were only in the 12th grade.
So I had a bit of basis of physics and math, and most of my astrophysics knowledge was not rooted in the math behind it. It was just rooted in sort of theoretical knowledge. So I think what this project helped me understand was how we can use math to model the universe. And it's just sort of mind-blowing.
Definitely, particularly as you were saying, the fact that you can then try and model light particles and see this interaction within the 4D space-time. Because again, I mean, modeling, was this something that you had learned on the course or that you had already developed partly beforehand? Because it's quite a high, it's not just modeling, it's quite a high level of modeling that you've been doing as part of your research.
So I had a slight experience of coding before before the course started, but I had never used code to create 3D models. So I think during my teacher assistant sessions, which happen once a week, and office hours, um, I think SEPA really helped us get an idea on how to code and how to model. So I think that was something I learned.
Because how was it then? Obviously, you've been developing this model and you said that you were still in the process of working on it and kind of testing it out. But how does that feel for you then when you see this program kind of come to life? Obviously, you said you began with charged particles within a flat space time and then have worked up to be within a 3D. So how has that been for you, kind of seeing these models develop and grow?
Yeah, I think it's definitely been rewarding. And so most of the basic models, I would actually code myself with the help of Dr. Bart and SEPA. But as we decided to take the project a bit further, um, during the course, Bart was teaching us from a textbook, and the textbook's author was Daniel Mayerson. He's also a theoretical physicist, and I'm sure he's pretty famous. And I think Dr. Bart helped me connect with him, and I've been developing on his code to try and reach the final project. So that's been really interesting as well as rewarding because I've been able to see progress, results, and I've just been documenting my findings so far.
Wow, that's amazing. So you've actually then also been working a bit in collaboration with Daniel.
Yeah,
Oh, that's cool. Yeah, kind of going even way beyond the textbook. That's amazing. Because then in terms of the results, how have you been measuring the results of your coding model, or what have been the results that you've been looking for within your work?
yeah. So for the initial projects, after I developed the coding model, I also developed the analytical and numerical solutions. So the analytical solution is one that's developed from the raw math. So, for example, if there's an equation, the analytical solution would be coding that equation, and the numerical solution would be coding the particle's movement. And what I did was I plot the error between the analytical, which is the raw math, and the numerical solution. And whenever that error crosses a certain boundary, then I know that there's either a mistake in my code or I have to reconfigure the settings. But so far, my error has been within a range of experimental accuracy. And I've also graphed how my error evolves around time. So we can sort of gauge till when our prediction or our model would satisfy the numerical solution and when it would not. And I've just pasted those in my research paper.
So yeah, it's amazing. That sounds like your model's clearly been working quite well if you've stayed within that error boundary. Because in terms of the research process itself, was this the first time that you'd kind of been involved in such scientific research and kind of doing the experiment and then writing up the papers afterwards?
So I've had a bit of exposure to research before. Like, as I said, I'm studying in the 12th grade and I'm studying in the IB diploma program. And as part of their curriculum, they require students to do some research. So I had a bit of idea on how to approach it. I think that aided and helped me.
That's good. And then what would you say there has there been anything that you've learned or skills that you've developed as part of the program, as part of doing this additional research?
Yeah, I think it definitely helped my academic writing skills because first things, it's something I'm passionate about, astrophysics. So I was able to commit myself to putting in extra effort, trying getting results, communicating with people across the world, such as Daniel. And I think that's helped me understand the research process and the process of publishing papers, as well as the process of writing.
Because what would you say would necessarily be some of the biggest challenges that you faced within this project?
I think just um, the scope to which it can be taken, because I think as Dr. Bart used to tell us that general relativity is something that's really, really difficult. And for him to sort of explain it to a high schooler, it would be difficult to explain it without losing the true essence. So I think personally, I found it a bit difficult to understand the maths behind it initially. But I think throughout the classes, he started showing us proofs, he started showing us models, images, and he provided us with his research papers. I think that helped me navigate through that. It gave me a sort of overview on what I'm learning and what I should expect to have, like, or the knowledge I should expect to have by the end of it.
So kind of having these teaching resources and being able to take it step by step during the program and build up that knowledge. Because you say it's a big topic to handle, and coming in at the very beginning, I imagine there is quite a lot of, how there's a journey that you go on in order to be able to understand it and reach that point where you're then, working on it and able to talk about what you've been working on. It's pretty cool. Because is this something that you think you would like to explore further potentially in the future? Kind of, would there be next steps that you would want to do around this research or just around astrophysics in general?
I think probably yeah, because I found this a really beneficial experience for me because I am interested in the research side of science. So it's definitely something I do look forward to continuing in the future.
Because I don't know, do you have any plans? Like, would you ever be interested in studying the sort of physics at university, or just seeing where you feel at the end of the IB?
So I will be applying to university later this year, and I am leaning towards doing a degree with either applied math, theoretical physics, and maybe computer science or math physics as a minor. And I think through the undergrad experience, I'll get more exposure to research and I can sort of hone in on exactly which category of astrophysical research I want to pursue further.
Because as you said, I think these are very complex topics, and they are hard to, the same way you said for Dr. Bart, they're hard to necessarily explain and to be able to clearly lay out. So how did you find the writing process as part of this research? So people then, at the end of your project, you produce a research paper. Were there challenges around that, trying to put down all of these complex ideas and modeling into one piece of writing?
I think, yeah, there were a few challenges associated with it, but I think since most of this writing is going to be read by people in the scientific community and like the community of people interested in astrophysics, I feel like to a certain extent, they should be able to relate and understand what I'm writing.
Yeah, I could see that. I guess, and if you'd already had some experience of writing up the research, then I guess you were already, more confident on what that paper should look like in terms of the structure and how to lay it out and things. Cool. And then just out of curiosity, I think you mentioned at the start that you also, part of your interest was in astrophysics was kind of from sci-fi movies. And I was wondering then, did you have any particular movies that were an inspiration for you for looking at this field, or that you've had in the back of your mind whilst doing the research?
Oh no, yeah, definitely. So I think Interstellar is a really popular one. And initially I was initially I felt that as my final research project, I would model black holes and sort of get an idea of what a black hole looks like in deep space. But I think what Interstellar taught me was the existence of wormholes, which was even crazier than black holes. And I think with the help of Dr. Bart and Seppa, we're working on extending the project to actually include a wormhole. So I think that played a pretty big role.
Oh, as I say, yeah, 'cause it's not something that gets focused on very much kind of within the general. Lots of people would talk about black holes, but wormholes are far less mentioned.
Yeah,
So yeah.
there's been a lot of research on black holes, and there's been a lot of um, ray traced images being created. But I felt that wormholes was relatively unique and I guess new knowledge, which was something I wanted to document as well.
And I guess also then for Dr. Bart and for Zappa, it's been very interesting in terms of seeing your project again go into a different area and the research. I don't know whether you know what they are working on themselves normally and whether your project ties in a bit with what they've been doing.
Yeah, actually, it's pretty similar. So I've recently been reading books by both of them while while I'm writing my paper, and I think it's helping me because they've done obviously at a much higher level, but they've done on similar lines to what I plan on completing in this paper. So it sort of gives me an idea of what my final project will look like and sort of acts as a guidance.
Because how has it been for you? Kind of how did you find that process of being able to work really one-on-one with some of these academics?
I think it was definitely beneficial. Like I said earlier, I had experience to research before, but none of that was as rigorous as I think the experience at CCIR. And I think with the rigor also helped build my commitment to learning and my quest for knowledge. So,
Because on a personal level, are there any skills or kind of things that you feel that you've developed as part of doing this project? Just in terms of your overall methods of working or approaches to a task like this?
uh, yeah, definitely. I think, like I mentioned before, like determination, academic writing, but I think it also, in some cases, like undertaking such research projects can also help you sort of understand what you're truly interested in. Because at the beginning, I had no clue about what relativity was, what space-time is. And I had the idea that maybe my research paper would be more governed towards deriving equations or producing new knowledge. I did not expect it to be modeling, but through the process, I actually really enjoyed it. And I really enjoyed coding the solutions. So I think that was something I definitely learned about myself.
It's really amazing. So yeah, you discovered a new area of interest or yeah, found a new thing that you might be more interested in looking at potentially in the future. Cool. And then sort of
Yeah.
last question, in terms of the CCIR experience, would this be something that you would recommend to people interested in the program?
Yeah, definitely. Because I feel like uh, my experience at the CCIR program was really fruitful, and it allowed me to explore um, the unknown, what I didn't know, and make meaningful contributions to my understanding of my interest. So I feel like other people who may have an interest but do not know where to begin research or how to go about it, CCI would provide a great opportunity for that. And I was also interested in interdisciplinary fields, and I think CCIR helped me sort of navigate between where to use math, where to use physics, and sort of combine both of them to create a holistic project. So I think it'll definitely help people who are looking to start research or have had experience to research but just need an opportunity to sort of further explore or delve deeper into what they enjoy learning.
Thank you. I'm really glad to hear that you had a positive experience, and I can definitely see what you mean about yeah having that holistic approach and being able to see where a project lies really at the intersection between two disciplines, how they can have a complementary role in working towards a particular problem. So I'm glad that you've been able to experience that as well. Well, thank you very much for talking to me today and telling us more about your project. It's been really cool to hear what you've been up to. Definitely sounds, very cutting edge stuff within the astrophysics community. So yeah, and I'm looking forward to hearing more about your next steps and seeing where you could go from here. Maybe one day you'll be the one whose textbook people are reading.
Yeah. Yeah, I think only time will tell.
We'll see. Wonderful. Yeah, well, thank you very much for talking to me today, and I wish you all the best for the future.
Yeah, thank you for having me here.